Good morning, good afternoon, or good evening, and welcome to today's SecurityBoulevard.com program, brought to you by Techstrong, AWS, and Aqua. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. You can engage with us in other ways on the right side of the screen by using the chat tab, and I'd like you to start warming that up for me right now by letting us know from where you are joining us. Feel free to also use this during the program to call out any good points you heard or maybe give your side of the input. And before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So our topic today is moving beyond SBOMs to secure the software supply chain. Now I'm joined by Nurit B.A. Lorai, sorry, Nurit, go-to-market manager at Aqua Security. We have Matt Coleman, EMEA Container Security Lead at IBM Security Services, and Dudi Matot, AWS Security Segment Business Lead at AWS. So Matt, Nurit, and Dudi, thank you all so much for joining me. Dudi, you want to get us kicked off?
Yes, thank you very much. And good morning, good afternoon, good evening, everyone. My name is Dudi Matot. I'm on the AWS side. I'd like to kick us off with speaking about the kind of shared responsibility. So whenever you start moving or considering moving workloads to cloud, you always want to look into the concept of shared responsibility model. And you want to differentiate between two modules. One is the off the cloud and in the cloud. What off the cloud means with respect to shared responsibility is that AWS takes care for you for all the host operating system, patching, network, the compute, etc. So you don't need to worry about that when moving or deploying workloads in AWS. On the other end, when you start deploying your application or developing a homegrown application on AWS, you need to think about all the security aspects of how you protect your data, how you make sure that the data is separated, the least privilege, patching the guest operating system, and so on. And this is typically where kind of with AWS, we're leveraging partners such as Aqua Security and IBM to help customers to address these challenges on AWS. So that's kind of the first and foremost for you to take care when moving to AWS. The second topic I want to speak about is things are different in the cloud. So I won't go into all these details. You can go and read through the slide, but on the left hand, you see kind of what's typical an on-premises environment would look like. So you, as the customer, need to take care of your own kind of end-to-end data center from the operating system to the network to data protection. Typically, you deployed many different silos solutions, sometimes up to 70 different siloed solutions. And the environment is kind of decentralized and require a lot of manual processes. When moving to AWS, I want to kind of double down on two aspects. One, everything is what's known to be API driven. So in this slide is the central control plane. The fact that everything is an API call allows you to track and log everything. So every movement, everything that you do, you can log and then look for kind of abnormal and build your governance around. The second thing is everything is automated. So this allows you to build security upfront, and what's known to be kind of the shift left trend, which essentially allows you to bake security early on whenever you start developing your application, looking into the different dependencies and your kind of CI/CD processes. So that's kind of the benefit that comes with cloud, and you can leverage these, leveraging CloudFormation templates, Terraform, etc. So these are kind of the main benefits that comes whenever you move your workloads to cloud. With the next slide, I want to kind of walk you quickly through the different native AWS security services offering. And we kind of, in this slide, I just kind of sliced the AWS native security services offering through the NIST CSF framework. So identify, protect, detect, respond, recover. So AWS allows you essentially to build and embed these services. So in the kind of the protect, you have services like identity, which comes most for free, which allows you to build a least privilege. Also manage your kind of keys and secrets and rotate them, which is super important also, especially with respect to the supply chain issue. You can leverage solutions such as Inspector to detect vulnerability within your application and dependencies, and automate through Lambda and CloudFormation. And at the end, super important to recover. So whenever someone break into the system or you suspect there is an issue, relatively easily to go back to the previously non-working environment. So AWS offers you different sets of native services, which are partners. So both Aqua and IBM most likely integrate with kind of out of the box. So with no further ado, I would move the floor to Nurit.
Okay. I'll take this one. Thank you. So to build on what's just been said there, I think before we kind of dig into some of the challenges facing organizations now and potentially some of the solutions to this, I think it's worth understanding why we're recommending that organizations need to be taking action now. And the reason for that is that, and some of you will probably be aware from the increased media coverage that's been seen recently, the number of supply chain attacks is on the increase. And as you can see from the quotes that are shown on this slide here, there's an expectation that the number of organizations experiencing attacks on their supply chain is going to increase over the coming years. And those supply chain attacks and those breaches can potentially have long-lasting impacts. There can be interruptions to operations. There could be lost revenue. And so what we need to be doing is to think about how we can put countermeasures in place for these risks. So what I've put together on this slide here is just to sort of put a few summary items, which we'll then go into a bit more detail on here. So we've got to think about the fact that at the moment there's potentially implicit trust in place. And that can be with the vendors that we're consuming third-party products from, and yet we don't necessarily have the transparency and visibility of their internal processes and the security they're putting around those products when we consume them. So we're not necessarily making decisions that have got all of the information that we need. We've also got the potential that we've got implicit trust built in within our own internal systems, and sometimes, and this might be something that we've got to look at, kind of shifting a bit of a cultural view on this to say, well, actually, we need to be running a model whereby any of the systems and the supporting functions that we're running, we need to actually build that trust rather than just saying because we built them, we should trust them. And we're also seeing an increase now, especially moving into the cloud native era here, where there is an increased adoption and use of open source software. And that same rule applies of where did it come from? What's its provenance? Why are we trusting it? What validation tests are we doing before we're bringing this open source software into our systems, using it and building systems around it? And we need to be thinking about that. And then we've also got this shift now to going to everything as code. So what we'll cover in the following slides is that we need to make sure that as an organization, we're moving beyond just looking at this as being an application development problem to solve. Okay, this is now everybody is creating things as code, whether it's the application or whether it's even the platform itself being created as configuration. We need to be thinking about applying all of these principles to that. So we'll cover those in a bit more detail later. Thank you, Nuri.
Amazing. So hopefully you can hear me okay. Beautiful. So what I wanted to kind of touch on are all of those risk vectors and how do they translate into what we're seeing in the wild, in the field. There's a lot of talk around software supply chain security and in specific software integrity. And first, what is software integrity and how can you actually achieve software integrity? I'll start more from the challenge side. And then as we go through the session today, we'll talk a little bit more about how to actually tackle it. But I think in terms of a challenge, in terms of a market challenge, a cybersecurity challenge is a complex one. In part because of the complexity of the software development lifecycle, and also as part of everything that is included in that, right? So I broke down the software integrity challenge into two core, let's say, things that we're really seeing in the field and are starting to shift the paradigm of how we treat security in the left. The first one being that today, as part of majority of software applications, you have two main components when it comes to code. You have your own code and you have third-party code. Now, there's a reason for why this differentiation is important, but also not that important. It is important because when it comes to a company's own code, right, that the code that my own internal developers are writing, there is an added level of governance, an added level of security that I can add and that I can enforce and that I can oversee, right? So we see a lot of companies that have been, let's say, deploying shift-left security and investing in shift-left security for a long time and are pretty confident in this specific part of that code. Now, this is important, but it's not the key important part. The reason being because today, a big part of these applications is third-party and open source code. And when it comes to the application, once it is built, once it is an artifact, once we're getting ready to release it into production, there's no real differentiation, right? Third-party, own code, at the end of the day, as long as it's a part of my application, it is my own and I need to take responsibility over it. So when it comes to open source and third-party code, we have a challenge in that not only do I need to validate that the open source package and the portfolio of open source packages that I am using are secure and validated, but each open source package, we can assume, has its own huge list of dependencies, right? It's like a huge dependency tree and dependencies of dependencies of dependencies that makes it really hard to ensure that what I am using is secure, right? It's no longer about that one thing. It's about everything that is included in that one thing. So to kind of take this idea and put a visual to it, I took one example package. The package is Koa. Not to say that this package is vulnerable, but this package is one used in a lot of software. So it's used by over 8,000 packages, and it itself has a lot of dependencies, right? It itself uses over 40 packages, right? So on the left, we are seeing Koa. Koa is a little dot in green. We are seeing its direct dependencies, which are around 15 in gray. And then we are seeing all of its indirect dependencies, which amount to around 30, totaling 40 in blue. Now, when I am evaluating Koa or any type of open source or third-party package for that use, I no longer can just look at Koa. I need to look at its entire map, at its entire dependency tree. The other part of it is that Koa in and of itself is used by 8,000 packages, right? In 5,000 of them in a direct manner and 3,000 of them in an indirect manner. So think about COA being the light blue instead of the green. Now, just think about a package that is used at this massive scale. It's a very similar scenario to what we had with Log4j being vulnerable or turning vulnerable. The effect is really, really massive scale. So on the one side, there's really a need to change how we oversee and how we choose the packages, the open source that we decide to be able to use as part of our own code. On the other side, we need to be dynamically tracking this, right, on a large scale in order to make sure that our applications, both before deployment and after being deployed, are maintained safe. So this is part one of the challenge. Part two of the challenge is that code, and what I just covered in the slide before, is only one part of software supply chain security. And I think this is something that we have really learned as a market, as an industry in the last 2 years in the hard way, right? By seeing a lot of software supply chain attacks that theoretically with traditional security checks should have been caught, but we realized that, hey, we were completely missing the mark as an industry and had a blind gap, right? So code is only one way to impact software integrity. So the question becomes, how do I actually close all of the windows? Meaning, when I'm looking at my software supply chain, there are multiple layers. Of course, there's a code and there's all of the vulnerabilities and risks that can be embedded or hidden within the code. But what about my development process, right? How do I make sure that what I eventually release to production is what I actually intended to release, that it went through the process, the security process that I intended it to go through? The third piece of that is, okay, let's assume that I did everything right and my code is secure and my process is also hardened. What about my infrastructure, right? If someone can enter any of the 5 core CI/CD tools that I'm using, or any of the 10 to 20 to 40 plugins that I'm using on top of them, and through that affect my development pipeline, then I didn't really do much with all of that code security and all of that process enforcement. So it really becomes a challenge of, first, how do I oversee on all of these different challenges? And third, how do I actually secure it, right? How do I actually enforce this in a way that is scalable, that is not super, super intrusive to my development cycle? So I took 2 examples to kind of illustrate what it looks like to target the development process and target the development infrastructure. On the left, we see an attack vector, which is through the trusted system with privileged access. So, for example, someone is able to access with privileged access because, let's say, for example, I didn't have multi-factor authentication enforced, or I didn't have the right branch protections enabled. So they're able to access one part of, let's say, my CI/CD system that has high impact, for example, my build. They make a change there that looks legitimate, and that isn't caught, right? Because they went through that trusted system with privileged access. This is related to what Matt said on his challenge slide. Any traditional code scan will not catch this, right? It's a matter of securing the infrastructure and having the right gates within the process to be able to catch drifts or any, let's say, variation from the standard or wanted process. Ultimately, if someone is able to enter through my build, through my source code management and make a change, that's a change that will affect my production. The second case is attacking one of the tools, one of the many deployment and or testing tools that we're using as part of this process. Think about it like this. I'm very lucky that I get to meet a lot of customers, a lot of accounts on a daily basis, and analyze and work with them through how they are, let's say, establishing their CI/CD. What I'm usually seeing in any enterprise or bigger account is anything ranging from 2 to 5 different CI/CD tools just for that SDLC. And on top of them, a lot of services and plugins that they're using, that their developers are using in order to make that process more effective. We talked a little bit about, let's say, gaining access to the build, which is a trusted system. But something else is if some vulnerability in one of the services, one of the plugins, one of those testing tools that I am using, that in and of itself is a trusted system, right? So let's imagine that one of my plugins becomes vulnerable, and because it's connected to my source code, it starts either leaking sensitive information from my code, or even worse, adding sensitive information and problematic information to my code. Again, a traditional vector that we don't typically look at, that will eventually have a significant impact in, whether my software supply chain, whether my official output, my official piece of software artifact will be secure or not. And these are two types of attacks that, again, the traditional code scanning tool will not be able to catch. So something really is needed to secure the process, to secure the infrastructure, and to look at things like hardening up the tools and vetting of the, let's say, security checks across the development cycle. Just if you cut it, the attack on the left is something like happened to SolarWinds, and the attack on the right is something like happened with CodeCove. Two attacks that I believe we'll tackle a little bit later when we talk about how to actually deal with this as a technology challenge. Matt?
Okay, thank you. So obviously we've gone through there a couple of the challenges. I think it's also worth just making sure that we look back and understand, that there are now directives coming out. There is legislation in place. There are proposals in place within the EU via the EU Cyber Resilience Act, for example, that are all focusing on the need to make sure that there is guidance that can be checked for compliance against, to make sure that the security is built into development processes and the artifacts that are being created are secure, and that there's also transparency there. And in fact, some of the main kind of goals of the Cyber Resilience Act, for example, is to make sure that the consumer of that product actually can use cybersecurity as a deciding factor when looking to select it. So what we might see as we go into the future is this shift of people actually looking at that as being one of the reasons why they might choose to utilize one product over another. And that can be both a product that is being used within the system or a product that is being used to create their system. So something to factor in there. Now, off the back of those directives, there is guidance coming about and guidance that's being updated. There's also guidance at kind of different levels, really, applicable to any organization. So, for example, the top one here is looking at how to identify and mitigate risks. The secure software development framework is more of a set of development practices that can be put in place to how to make sure that your organization is secure. How do you secure the software that you are releasing? How do you make sure that that software has been well secured when it's constructed, and also how to remediate vulnerabilities that come about post-release as well. So it gives those good practices across the full delivery lifecycle. Then you've got the CIS software supply chain security guidance, which focuses on the enterprise development cycle, and it actually gives examples as to how to implement security into the pipeline and the components itself. So there are some specifics around configuration on the different components, as well as general practices. So there's these differing layers that we can see of guidance that we can look to utilize if we're looking to align either through just wanting to seek out good practice or aligning to meet compliance in line with legislation itself. And then finally, at the bottom, you've got the SALSA, so software supply chain levels for software artifacts. And this is actually a framework that can be used to assess the maturity of your pipeline that is and the integrity of the artifacts that it's creating. So there's a few different things out there that you can look to align with. And you might, like I say, you might be driven to do this because you're looking at it from a good security practice point of view, but you also might be driven to it by the legislation that is now coming into place in various different regions. Thank you.
Okay, hopefully we're good now. Sorry for the double noise. Okay, so thank you very much, Matt. And I think it was a nice leeway into this slide where I wanted to talk a little bit more about one of those directives and one of those guidelines, specifically the executive order from President Biden and the Secure Software Development Framework. I wanted to talk about this more from a historical standpoint rather than the compliance requirement itself. So In May of 2021, the executive order on improving the nation's cybersecurity was released or was published, and one of the sections, Section 4, really focused for the first time on developing software supply chain security standards and guidelines, and really a compliance framework around this. This executive order and this specific section was partly in response of SolarWinds and really aiming to prevent future instances of it, which I think it's super interesting because, again, for the first time, it talked about software supply chain or shift-left security in a wider context than just the code, really highlighting areas like development infrastructure, development process, software bill of materials, attestation, integrity, and more. And what it called for, what this order called for, is to have official guidelines and directives created on how to actually achieve compliance of software supply chain security. Now, in response to that, NIST released the Secure Software Development Framework, which took the sections of 4E from the executive order and broke them down into 42 controls or practices, real practical ways to actually achieve compliance with the order. We don't have time, unfortunately, to go over the 42 controls, but I did want to take the sections of the executive order of the Section 4 to explain kind of the breadth of it, right? So first, we see that the first thing that we hit is secure configuration of the development environments, right? Making sure that source code management, that build, that deployment tool, that the Artifactory are securely configured, and that one, no one that shouldn't be accessing it accesses it, but two, that no sensitive or private information can become public. Section number 2 is talking a little bit more about the code, right? So making sure not only that the code is secure, but that the sources of the code are trusted, and that any vulnerabilities, risks, misconfigurations have actively been remediated, right? So this is also asking for something new, right? I want to see that you found things and that you solved things as you went through the SDLC. Third piece is really talking about software bill of materials. Anything that you release, anything that goes to production, anything that someone will consume, you now need to have a software bill of materials, right? I guess in hindsight of SolarWinds and Log4j and all of these software supply chain attacks, it feels like a given. Of course, we need to know what's inside of the software to understand if something puts us at risk or not. But at the time, it was really kind of not a completely new concept, but a new concept at this scale. Of course, Section 4 is talking about vulnerability disclosure, which I won't touch so much, but Section 5 and 6 are talking about maintaining a secure development process, right? Which is basically saying, hey, any software that you want to deem as secure, you need to be able to show me that it actually went through a secure path, right? Which security checks did you implement at which point? How do you validate that those actually ran, that those actually passed? And the last point is around the integrity and provenance of open source software in use, which I think is really interesting based on challenge number 1 that I mentioned. Integrity is a tough challenge when it comes to open source because we can no longer look at just the package, but we need to look at the entire context and dependencies of that package, right? So this is, I think, also asking for the logic behind why did you choose to use this package? How did you deem it secure and available and for your developers to actually use in your application? So these are the core areas of the executive order, Section 4, in the context of software supply chain security. Really a historic event in that it really puts software supply chain attacks and the type of security solutions or features needed in order to prevent these type of attacks. And the last piece, of course, is that it led NIST to release this Secure Software Development Framework that takes these relatively high-level sections and breaks them down into real things that you need to turn on, turn off, enable into your pipeline, and so on. I did just want to touch on another of the frameworks that Matt mentioned, which is the Center of Internet Security Software Supply Chain Security Benchmark. I'm part of Aqua, and as part of Aqua, we're very proud to have partnered with CIS on this. I think when we started the work on this, and it was a long cycle, of course, as you're developing any type of benchmark, there was really a need to take all of the different type of guidelines and initial frameworks around software supply chain security, which were relatively high level. So things like SALSA, things like CNCF, software supply chain security framework, and take them into actual, again, controls, right? Things within configuration, within the build process, within the deployment process, within the Artifactory process that you actually need to turn on, turn off, toggle, enable, and so on. So we really partner with them on this and develop this in tandem with them and many other market leaders. And the core portion that I wanted to mention about this is that when we were building this, whenever it came to the software supply chain and the pre-deployment part of the cycle, so everything from the source code management to the build and testing, we looked at it in 3 core layers at each stage, right? So from source code management and from the CI, we were looking to both secure, 1, the code. And when I'm talking about code, I'm talking about all of the different types of risks within code. 2, regarding the process. So 1, it was enabling, let's say, policies and suppressions, kind of a policy guideline within the company, and actually being able to enforce that throughout the development cycle, which also included pipeline security, pipeline scanning. So actually looking at how the pipeline is built to run and being able to validate that, as well as the automatic generation of a software bill of materials. But more than that, taking that process and looking at it to validate the entire security history of that artifact. And the last piece is infrastructure security. So not only code, not only process, also looking at the way each development tool is configured, making sure we have all of the right configurations, branch protections, minimum reviewers, activity levels, auditing, permissions, and so on. Really establishing a zero trust environment within the development tools themselves. This came out kind of in the middle of SALSA, CNCF, and the later NIST SSDF, which is very positive because the benchmark and these really practical controls are really aligned with the practices set out in the SSDF.
Thanks, Stuart. So what we now want to look to cover then is how IBM Security and Aqua Security working together provide an approach that covers the end-to-end supply chain software supply chain security. And the idea here is that it's moving very much to build that model of verification and the importance of it, as well as also looking to say, well, actually, we've got to support this everything as code approach that is being utilized now. And we've got to have that defense in depth that Nurit is also mentioning there. So yes, we've got to have the processes for securing the software that is going through the pipeline, but we've also got to make sure that we are securing the pipeline itself. And that's where the Aqua Security tool comes in, with the ability to provide that automated analysis and then visibility around the remediation that needs to be put in place. So all of this works together to nicely cover off people, process, and technology. Next slide, please. Okay, so we've mentioned a few times now this approach of everything as code and why this is bigger than just a conversation for application developers to have. So what I've looked to do here is to produce a simplified model of a supply chain. So you've got the input, which goes into a store, so a code repository. You then build and test that, bringing in dependencies from outside. You've then got an output produced, so this will be your build artifact of sorts, would go into an output store, so this can be a registry or a repository ahead of them being deployed into an environment. So as you can see from the left-hand side there, with this everything as code, we're not just looking at applications needing to adhere to this model. It's the entire stack. So it can be those container images, it can be the workloads that specify how those containers are going to be deployed. You might have configuration files that you're deploying as well. Virtual machine images need to be created. The pipeline and tasks within it itself are going to be defined as code ideally. And then you've got the platform infrastructure as code. So, for example, configuring AWS as code. And then you've also got those dependencies coming in from the top there. So where you might traditionally have thought for applications, it might be the libraries, the dependencies, similar to the model that Nurit showed you previously on some of the earlier slides. You've also got to think about what are those dependencies and third-party items that need to be brought in for these other items that are being created as code and configuration now. You just click through a few times, please, Nurit, just to bring up the rest of it. Thank you. So we're building on a traditional model of we've got to make sure that we are securing the source. So from an application perspective, it's performing that source composition analysis. It's making sure that you've got the controls over the repository prior to doing the build work and so on. So all of this is in place. But what we're now starting to look at a little bit on this slide here is also the fact that you've got to make sure that this is applying to everything that is running through there. So you need the equivalent processes in place to say, well, actually, how am I going to validate my container image configuration file before I build it, as I build it, and then after I've built it, as it becomes an output, all the way down to, as I've said there, the platform infrastructure as code. We again should be looking at the configuration. We should be looking to test that in the pipeline and say, is this configured as securely as possible? But also when we're looking to create, for example, pipeline tasks, it may well be that actually we're going to bring in third-party containers to actually run those tasks in our pipeline. And we need to think about the security of those. What verification, what validation have we done on that? Because that is going to actually form our build and test platform. So we need to make sure that we've got that build integrity there. And then obviously for the outputs, we need to make sure that we can go through a process of validation before we deploy those as well. So there's a bit of a kind of, when we were talking about this, when we were putting these slides together, talking about almost a bit of an inception model going on, because that build and test box in the middle, if you imagine that we're talking about the pipeline itself, those pipeline tasks have got to go through a pipeline themselves, which has got to validate that they are secure enough to form this pipeline that might be used for the applications. So it really is a team sport here. Everyone's got to think about this and everyone's got to play their role and think about how we're going to secure this together. And that's why the time has got to be taken to sit there and actually think about these different concepts, put together a strategy and design around that, and plan out how you are going to build security into the multiple layers and the multiple different types of pipelines that you will need to run your system successfully. Next slide, please. Okay, yeah, on to the next one. Thank you. So what I've put together here is just to run through a kind of a few personas around this, really, just to try and explain this a bit more. And the key thing here is that we've got to move away from this model where we are just implicitly trusting the systems and the artifacts, and so we've got to move to verify them. So you've got Tina on the left-hand side here, who's an application developer. And application as code has been around for a long time, and therefore the practices around trying to secure that code, secure the dependencies that use it, is a bit more commonplace than for the equivalents on the infrastructure side, on the container side, and workloads and so on. Now, she's going to make sure that her application is secure, and that's going to be something that she can ideally do on her own workstation through a shift-left approach of enabling her on her workstation in the IDE to get feedback as to whether her code is secure, whether the dependencies have got vulnerabilities, before then going through that centralized formal pipeline where those tests are going to be repeated to then produce a secure artifact. Now, what we've got to factor in on the pipeline side of things is that the artifact is going to come out the other side of that and likely is going to be signed to say, yes, I've come through this process, and it's going to be signed by a key that is stored in a secure fashion, that we therefore have a trust around that key. But actually, if we were to just sign the artifact, all we've really said is, yes, we've produced this. But actually, when it comes to then consuming that artifact into the platform that Diana's putting together, they need to make sure that they're taking the steps to verify this. Just because we've signed it and said we've created it, well, actually, what did it go through before it was released and before I'm consuming it? Do I want to consume it into my environment? We need to be looking at it in that way of, right, I want to verify this before I say yes, I'd like to accept this. And so the key thing there is to make sure that we have the ability to understand the provenance of that artifact. And so we need to attach an attestation to that image as well. And that would be a signed attestation, again, controlled with keys and so on. And that attestation would give us a view as to exactly what was performed in the pipeline and what the tools are that are used in the pipeline. You can start to build up that story, that supporting story for that artifact that says, this is where I came from, this is what I've been through, I am secure because I have gone through these things, this is why you should trust me. And then it can be a conscious decision for that deployment into the runtime environment to say, yeah, you've passed all the checks, these are the things I wanted to see, these are the tests that you've gone through, these are the policies that you've been checked against. I can see all of that has taken place, and therefore I'm in a position now to trust. But what we've also got to make sure is that the pipeline itself that we're now looking to trust has been built in a secure fashion. So we're going to say that, yes, the policies that you've gone through and the checks that you've gone through are sufficient. But if we don't have any trust in the components that are providing those policies, providing those tests, then again, you're in the situation where, why are you letting that artifact into your environment? How do you know that it is secure and therefore should be put in there? And that's where the secure setup, but also that analysis, also that inception model that we've spoken about as well, and why we need to make sure we're performing these checks on anything that's brought in and anything that's configured, are so important, because we've got to be putting ourselves into a position whereby we look at the artifact that comes out of that pipeline and the attestation attached to it, and we say, because you've gone all through all of these things, because you've gone through that pipeline, I am happy to release you into the environment. So there's lots of moving parts that all need to come together here, and all of these teams need to work together and making sure that they're following these secure processes, and that therefore there's a bit of a potential enablement piece and education piece around this to make sure that you're helping them understand what a secure mode of operating is around a supply chain, but also how to put those processes in place and how to use technology to enable them. Next slide, please. So for organizations that are looking to make sure that they have got secure software supply chains, one of the first things that you might look to do, for example, is to obtain a tactical view and understand the current risk that might be impacting your software supply chain. One of the things that we at IBM can offer is a rapid assessment. It will help you understand the security posture of your development environment and tools. It gives you a view of any vulnerabilities that are impacting those environments and tools. And then after having done all of that analysis, which takes in the region of a couple of weeks, there's then a final assessment that we can produce, which details that analysis, the key findings that have come out of it, but also more importantly puts together the remediation recommendations to actually attain a secure software supply chain, which then might form of a follow-up piece of work or help define a roadmap to get you to a target state and make sure that you are secure, and if you need to align with any legislation and directives, that you are doing so. Next slide, please. Now, further to the rapid assessment, we've also got the mechanism in place to put together a strategic roadmap and design here. So working with your team, we can help do a more strategic assessment, looking in more depth at the processes around this. But we also want to make sure that when it comes to putting together a strategy, that is very much focused on the people, process and technology that needs to be put into place here. And keyly alongside that, we've got to make sure that in order to transform any internal culture around this and understanding, there's a lot of education and enablement that needs to be done for the internal teams, and so we can assist with that as well. And the idea is that we help you define and envisage a solution that is going to achieve what you need, putting that together into a roadmap, defining those processes, defining the architecture, planning out those team enablement activities that can facilitate this, to then allow that next stage to occur, which is then to move on to the rollout, the MVPs, the integration, that kind of thing. And the idea here is that it's rolled out initially on a small scale to select teams that you wish to adopt this process. And the idea then is that you can test the processes you're putting in place, test the education, the enablement, test the technology, get everybody comfortable using it, understand the benefits and see the results coming of that before you then decide that you'd wish to roll that out on a broader scale across the rest of the organization. And the key thing here is to look at all the areas that we've spoken about through the earlier parts of this presentation. So looking at securing the code and configuration going through it, securing the process around the pipeline and the environment, but also securing that infrastructure underneath to make sure that all of those layers are secure, to make sure that you are greatly increasing the security posture of the software supply chain that you have in place. Next slide, please. And as part of that process, enablement's absolutely key. We want to work with you and your teams to help them be empowered to be in a position to then taking that tool forward, which here we're obviously talking about Aqua and the functionality that it has, to then make sure that vulnerability management, policy management and threat modeling is something that your team can perform, or we can also offer managed services in this area to assist you. And the idea is to utilize that underlying technology here, where it provides that code scanning, has open source health checks to make recommendations as to what should be used, as well as all of these automated checks around the pipeline itself, to hopefully kind of build up that posture around the supply chain itself. Next slide, please. Okay, and I'll hand back to you.
Amazing. And I may use your slide, Matt, for a second. To talk a little bit about how the secure DevOps service really ties nicely with, one, the Aqua technology, our software supply chain security technology, and how that also ties down with all of the directives that we mentioned before. So the beauty of the Aqua software supply chain security solution is that it really takes a look at those challenges that I mentioned and tackles them with the mentality of, let's do the most with the least, right? So basically what we do is we integrate into that SDLC. So we have native integrations with most source code management and CI providers today. And we do those 3 layers of security today, right? So on the one side, we're doing that universal code scanning. So looking at all types of code vulnerabilities and risks. So open source vulnerabilities, secrets, misconfigurations, as well as the actual open source health of the packages in use. We are also looking at the process itself. That means we have a very strong policy engine that you can use to automate security in the development workflow. We also have the ability to scan and enforce pipeline steps. And we also have the capacity to validate those pipeline steps and the overall artifact security history with our next generation software bill of materials. And the last piece is the CI/CD, or software supply chain posture management, where we are taking those controls in the CIS benchmarks and in line with SSDF, and really first checking them automatically based on those integration points, but also auditing them and making sure that you're ready to attest to the security of your overall supply chain. Now, I just wanted to give that very short explanation of what our technology does and how it fits into the overall picture that we've been painting, to close up with this slide. Now, when there is a good implementation, when all of these pillars, all of these, on the one side, let's say directives, guidelines are taken into account, technology is put into place, and people and processes are enabled and planned out and, let's say, taken out effectively, like Matt was mentioning, the impact of a good implementation is really significant. And it's something that we specifically have been really able to quantify with our customer base. So I wanted to talk about some of the metrics that we see reliably with these software supply chain security deployments in the way that Matt was explaining them. First one is a reduction of cost of remediation, right? When we take vulnerability patching into the development flow and we empower developers to fix automatically as they introduce, as opposed to waiting until a later stage in the SDLC to find and try to fix, we really reduce the cost of remediation from expensive, and obviously the later in the process, the more expensive, to minimal to none when I am doing it in the moment, in real time, as these risks are being introduced. The second item is, or the second metric is really protecting revenue at risk by making sure that everything that we release is secure and attested. And I'm putting an emphasis on everything. Matt mentioned earlier in the session, and he knew that I was very excited for him to talk on this topic, that we are good at securing code. So we should try to secure everything as code, right? We can look and treat everything as code. That is applications, that is images, that is workload, that is configuration files, and so on. So making sure that everything that we release is, one, secure, because it went through the right secure process, and that we can show that process, but also attested, right? Do I have the right artifact of security that I can share to make sure and to show that what I released actually did went through what I wanted it to go through. We see that when we put these, let's say, features or technology pieces into place to make sure that in order for something to be released, it needs to have this attestation, it needs to have this visibility at the last stage of the process of, hey, this is everything that I went through and this is why I'm ready for deployment. Really, it reduces the risk in production in runtime significantly. The last metric is when we increase everything as code, and we really do implement this, let's say, one, treating everything in this same way and through the same secure golden pipeline, but also starting to connect the dots between the different stages of the application lifecycle, all the way from the code through the cloud, through the workload. We're really able to increase security productivity by reducing the total cost of both ownership and orchestration of security, right? Think about it this way, and I'll just say one last example to illustrate. Let's take the case of a Log4j, right? A open source attack or an open source vulnerability that made many workloads vulnerable in production. In the best case scenario, a company has both a security solution on the code side and a security solution on the runtime side. That means that they're able to stop anything new that has Log4j from being deployed and identify any workload that has this vulnerability and is able to neutralize that risk. That is good. That is stage one. But what about actually patching, actually fixing, actually cleaning that vulnerability in my workloads? That requires for me to be able to link that data from which workloads are at risk from which of my 10,000 code repositories are actually linked to that risk. If you have two solutions that are not communicating with each other, the realistic way that you'll do it is you're going to start pulling a lot of Excel sheets and trying to connect the dots between them. So really shifting the paradigm and starting to think about solutions like Aqua that automatically connect the dots between them to really reduce let's say the cost of an incident, the cost of trying to orchestrate multiple different security tools in the same space. So the impact of a good implementation is significant. So we will kind of close it off with a few nice call to actions, and then we'll open it up for questions. So we'll do it in the order that we have here. So Matt, if you want to talk a little bit about IBM.
Yeah, thank you. So as mentioned, we have a service around this from IBM Security, so we can look to perform a rapid assessment of your software supply chain security, or we have the more strategic offerings as well if you wish to look at full strategy and design around software supply chain security. So yeah, I think we're going to be sharing these slides and making these links available. So if you would like to reach out, please do click on that link there to talk to an IBM expert about this, and we can help you and assist your organization with making sure that your supply chain is secure. Thank you.
And from the Aqua side, of course, if you want to hear more details or see everything that I've been talking about live, feel free to contact us for more details and a demo or just a talk around our supply chain security strategy and how we can help with yours. We're also available via the marketplace. So if you go into AWS in the marketplace, you'll find some of our offerings. So it's another way to reach us. And if you're not ready to talk to anyone yet, but you do want to, let's say, explore a little bit more about what we talked today, I do highly recommend checking out our CIS Software Supply Chain Security Benchmark. Overall as an industry guideline and as a control to look at and to start organizing the thoughts around how do I tackle this big challenge. It's a great place to start. So with that being said, Dudi, I don't know if you want to throw in some last words.
No, I think I'll leave a couple of minutes for more folks to, in case you have questions, to the team.
So it looks like we did receive a question, and it reads, can you please suggest a few good open source security tools which can be integrated with security posture?
I'm happy to give that a go. Sorry, we have an issue with me turning my microphone on and you're getting the feedback there. Lots of different open source tools can be utilized as part of pipeline security. I will let Nurit cover a few of the Aqua ones, such as Trivy and Chainbench, shortly, but there are also multiple tools out there from the likes of OWASP. So if you're looking at trying to understand any vulnerabilities and dependencies you have, some good tools out there are Dependency Check and Dependency Track. So it's worth having a look at those. If you're looking at vulnerability management tools, there's another tool, Defect Dojo, for example, from OWASP. But like I say, there are also open source tools that Aqua releases. So I will mute myself and I'll let you cover those, Nuri.
So first, I wanted to apologize. And second, I wanted to say, you don't get beauty without pain. So you don't get Matt's amazing insights without the pain from my microphone. I did want to say at Aqua, we are very, proud of our contribution to the open source community, specifically when it comes to the software supply chain, because we have other open source tools, but specifically to this, I think Trivy as a scanning engine is a great place to start in implementing security scans across the development pipeline, fully open source, maintained by our team. And the second piece is something that we released not so long ago, which is called Toolchain, another open source tool maintained by the Aqua family that takes that CIS benchmark, some of the most important rules, 25 of them specifically, and automatically audits them against the environment that you're running the open source tool in. So I think as a place to start, those two are great. And obviously, as you start to want to scale those or manage those in a more organized way, that's when the enterprise tools come in.
I'll just add to that. Thank you. I think the key thing is, Nuri, what you were saying earlier in terms of things like total cost of ownership and so on, about trying to have a unified platform as well. One of the things that we will quite often talk about with clients is the fact that, yes, you can look to stitch together 10, 15, 20 different tools to achieve good end-to-end security posture. But the overhead is you've then got to integrate those. You've got to get the information from one into the other, and so on. And so you've got to have the mechanism that supports that. And you've got to develop the processes around that as well that make sure that you've got that full end-to-end visibility across all of your components. It's something to really be aware of and consider, depending again on the scale of how you're operating and things like that, just to make sure that you do factor in that sometimes having lots of separate tools to achieve it isn't necessarily as kind of good in terms of having that unified approach as having a single platform to do so.
Well, all right, that seems to be all the questions that we've received so far. So I'm going to go ahead and give away a couple of gift cards, and then we'll do some closing housekeeping. And also, I am seeing questions about the slides. We are going to see if we can get all those slides emailed to you after the fact. So hopefully we can get those into your inbox pretty soon. So Nuri, Matt, and Duty, thank you so much for joining me today. I really appreciate the time that it takes out of your schedule to not only put the presentations together, but to dedicate the full hour to come here and join us on Techstrong Learning. So I really appreciate all of that. I would also like to remind our audience that this session was recorded. Should you want to rewatch or share with a friend, the on-demand recording will be made available shortly after this. You should be receiving an email with a link to access that recording. Or, of course, you can find it living on the Security Boulevard website at securityboulevard.com/webinars. The 4 winners of our $25 Amazon gift card drawing are Darlene L., Javier D., Lydia S., and Chalks R. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. It should be there in about the next 48 hours. If you don't happen to see one, do check your spam folder just in case it gets filtered out. I'd like to thank AWS and Aqua for sponsoring our program today. And to everyone who has joined us, thank you so much for being here. We really appreciate your time, and we also really appreciate your feedback. So If you wouldn't mind filling out the survey that's about to pop up on your screen, let us know what you liked about our program or maybe what you'd like to see on an upcoming panel. Otherwise, we do hope to see everyone at an upcoming Techstrong learning experience. Have a great rest of your day, and Duty, Nurit, and Matt, thank you all once more.
Thank you very much.
Thank you.